In this lesson, we're going to learn how to write linear equations given tables and graphs. My target population was my students that are diagnosed or classified as gifted students. So these students fall way below the average line on MAP scores for grade level. So again, that target was to write a linear equation given a table or graph. You could see that there's a content standard. So throughout this lesson, the students are going to be in the role of the teacher where they have to learn how to write the linear equations given the tables and graphs. They're going to have a graphic organizer. They're going to be accountable for discussing using discussion questions to hold each other accountable. And I'm going to be listening to their conversations to check their comprehension. So at the beginning of the lesson, students are going to number themselves off in their groups, 1 through 3. I call this their home groups. And then students are going to move into their groups based on their numbers. So all the 1s are going to get together, all the 2s, and all the 3s are going to get together. These form extra groups where the students are going to learn how to write their given equation either from a table or a graph using the task that is at their table. Students are going to work cooperatively together and then answer those questions, the example questions on the task that's going to be given, which you'll see up and coming on the next slide. Once the students are done and they've answered their questions, they understand the process, they're going to orally discuss 3 discussion questions and then write their answers to those questions to demonstrate their understanding. But as well, this is how they're going to hold their other group members accountable for listening. So once the students are done, they're going to go ahead and get back into their home groups, which is their original seats, and they're going to share their process. They're going to share their examples. They're going to have the students write down their examples, share their process, and then they're going to ask their students those 3 comprehension questions at the end in a discussion, and then the other students are going to write down their answers to keep further new information in their notes. At the end of the lesson, all students are going to answer an exit slip question, 4 questions, seeing if they can answer how to write the linear equations. So here we're going to start out with the course connections for this lesson. So how am I going to gauge students? So this strategy is called the jigsaw strategy, and they keep students accountable for their information because they are in charge of teaching their original group members the information. Students also engage in multiple intelligence because they are incorporating all these different skills. They're learning visually from the examples, they're moving kinesthetically around the room, they're looking for patterns, mathematical reasoning skills, building on their prior knowledge, sharing with each other, working on their interpersonal skills. As well as this really is a lesson having them construct their own learning because I'm just giving them hints through the task and the information, and they're really building on their prior knowledge to learn their information and share it. This lesson really focuses on sticking with it. Students have to persevere through these problems in order to find out and write their linear equations for the examples because I am not going over through how to write these linear equations in direct instruction. They have to analyze the examples, analyze their steps, build on their prior knowledge to learn how to write these linear equations from tables and graphs. The lesson also builds on student rapport, their social emotional learning. They really have to establish relationship with their peers so that they can work well enough together so they are able to come up with this information well enough, learn it well enough so that they can teach their group members, share their knowledge, and help them throughout their process. So we're going to go ahead and see what they're going to start out with. So this is their prior knowledge. So this is our whole group part of the lesson, which I kind of talked about in the launch. Is students are going to have to build on their information about, they're going to have to learn their information, build on this. So we kind of start out with this example about how we write linear equations. So students, we talk about how do we write a linear equation given the information. So if we have a slope, given the slope, what do we do with that y-intercept? How do we put this together? So we come up with our y equals, our slope takes for the letter m. This is all information that they know. So we're going to have negative 14. X goes next to our slope plus our y-intercept. This is something that we've already known, we talked about. So what do we need to make a linear equation? We need a slope and we need a y-intercept. So that's just kind of prior knowledge starting the lesson. And then next, our students are going to go ahead and move on to their, so this is where they're going to meet in their expert groups. So students are going to have, this is their task. This is at their table, group 1, writing linear equations from a graph. They write down these examples. This is the process. This is where students have their organizer. They're going to draw in those examples where it says example 1, example 2, example 3. So we're going to talk about what do we need to find first? Well, I can identify this point right here. That's going to be my y-intercept. And this is all information students know. I am just giving them their background knowledge about the process and the steps. They'll carry out that process to where it says process over there. This is their organizer. So this is their task sheet right there where it says task/help sheet. Then the student's going to see, well, what do I need to know? What does M mean? Well, I know M is the slope. So now I'm going to find another point on the line. Where am I point on the line? Up here, right? So we're going to go 1, 2, 3 units up, because when we do slope on a graph, we do rise over run. So we go 3 units up and 1 unit over. So rise is 3 over 1. When we divide, this becomes 3. Our slope is 3. So they're going to write find rise over run for step 2. Now we're going to put it all together. We have an equation. Y equals 3x plus 2, because this is my y-intercept. Oh, and then they're going to say, well, what about a horizontal line? We know that a horizontal line, M is 0. So it's going to be at this value, y equals 4. And vertical lines, we know the slope is undefined. It's impossible because there is no rise, there is no run. We are not moving left to right. So that's going to be 0. We can't divide by 0. So I just going to go on this number, and that's my equation, x equals 3. Okay? Students are going to talk about this in their group, and then they're going to go to the next slide together where they're answering these discussion questions. How do you find slope from a graph given a line? Well, we talked about this. What do I need from finding the slope? I'm going to need my M, right? How do I find slope from a graph given a line? M, which is my 2 points. We do rise over run. How do I find the y-intercept on the y-axis, the points that cross the y-axis? And how do I make an equation? The students are going to combine examples 1 and example 2 together to say that I have my slope, I have my y-intercept. I put it in the form y equals mx plus b. I take my slope, put it in for m, I take my y-intercept and replace it for b. And again, this is all prior knowledge. Students are just discussing these 3 questions together in their groups. So now I'm going to go ahead and talk about example 2. This is going to be my group number 2. Their target is writing equations from tables with a y-intercept. So they're going to have, when we have y equals mx plus b, they're going to have the y-intercept in the table. So they're looking for, when 0 is for x, they're looking for this y value. So again, this is the task sheet students will have in their groups. Their goals right here, writing linear equations in the form y equals mx plus b from this table. Oh, today we're going to go ahead and go find my process. My process is to go here. What do I need to find slope? How do I find m from a table? Change in y over change in x. Change mean how is my y going up or down? I see it's 5 over -4. I'm slowly getting more negative. I'm owing more money to my friends. And then now I'm going to go ahead and find my equation. Oh, wait, first I have to find my b value. I'm looking where x is 0. So this is my b value. So I'm going to get y equals, my slope was 5 over -4x plus 2. That's all this information is going to go in their task sheet where it says example 1. Example 2, here's my y-intercept. And what happens if I go out of order? It's okay as long as I make my equation, y equals mx plus b. I'm going to go ahead and find my slope, y over x. Y's are going up by -1. I have -2. 2 negatives I know is a positive. So for this one, y equals 1/2 x. -4 is my equation going here. And now students are going to go ahead and move, discuss with their groups, discussion questions. How do I find slope from a table? Change in y over change in x. How do I identify the y-intercept in a table? I look for where x is equal to 0. And then I write down the y number. That's my y-intercept. How do I make an equation from a table in slope-intercept form? I put my m, which is my slope, in for the y equals mx plus b. And students, of course, have complete sentences for this, but for this purpose, I'm just jotting down the important information. and they'll take their y-intercept value, plug it in for b, so x, put in the b value for that one, as you saw in that example. Okay, now we're going to our last group. Students in this group have no y-intercept. So this one is the most challenging one because students have to go and look for the y-intercept. So again, change in y over change in x, which you just learned. So for this one, we have y over x. It's going to be positive 1 because we're slowly going our friends more money over positive 2. We're growing by 2. So now I have to go ahead and work backwards and find my y-intercept. My friends are going to be confused how to do this, but they know that we are looking. How do I find no y-intercept? So we look for where x is equal to 0. So I'm going to go ahead and try to make x 0. How can I make x 0? I'm actually going to go backwards. So if I go backwards, I'm actually not adding 2. Right here we have positive 2. I'm going to subtract 2. So 2 minus 2 gives me 0. And then how do I get my y values? I'm going to go backwards using my rate of change for my y value. Here, my y value was 1. So I'm going to go backwards. And if we go add 1, I'm going to get to negative 3. So I don't want to do that. So I got to go the opposite. So it's going to be negative 5. So my equation for this one is y equals 1/2 x minus 5. Okay, so they got to think what is the x value for the y-intercepts? We're going to make that equation y equals mx plus. Okay, and then they'll do this example 2 together. In their groups, they'll see that their slope changing y over x is going to be negative 3 over 3, which is reduces to negative 1. So y equals negative 1x plus b. And then they're going to work together to figure out how do I get that value for x, that question. Their answer will go in for example 2. I'm going to move on just for some time. So then they're going to go ahead and answer questions together in their tables. How do you find the y-intercept table when there is none, right? We have to use the rate of change to find the y-intercept. We have to create it, okay? How do I find the slope from a table? Again, we did change in y over change in x. How is it going up or down? How is it going up or down? Increasing or decreasing? How do I write a linear equation from a table? Given no y-intercept. So they're going to go ahead and combine their answers from 1 and 2, right? First, we're going to have to find the y-intercept by going backwards, right? And again, students are going to have complete sentences for this. Find the y-intercept by going backwards. And then 2, calculate our slope. Put in y equals mx plus b form, okay? All right, moving on. So now this is our exit step. So this is our closure. This is our assessment for students. Can they answer writing these equations? Can their answer be in y equals mx plus b? Can they solve for the slope? Can they solve for their y-intercept? So here, this was our prior knowledge example. Here was group 2, because here's our y-intercept, here's group number 3, and here's group number 1. So each of these are going to go ahead and write their y-intercepts and their slopes in their final equation to answer our question of our learning target. How do I write a linear equation given a y-intercept and given a slope? M slope, B for our y-intercept. Students will answer that independently by themselves, and if we have time, we go over, we peer assess. How did we do? What is our level of learning? 4, 3, 2, and 1. 4, I'm an all-star, I can teach. 1, I need help, okay? And then there are my references that I used for my relationship and my course connections. So that was my lesson on how to write linear equations given a table and a graph using the jigsaw strategy to engage students and help them be accountable and incorporate the constructive theory and multiple intelligence in my lesson. So this was about a 75-minute lesson, and students were able to get through everything as they held each other accountable and share the knowledge that they learned together.